Dear viewer, this is Excel Science Tuition, and today we are going to study about the kinetic theory of matter. So welcome, and let's begin our lesson for today. First, I'd like to encourage you and welcome you to this lesson by telling you this. Set your own goals in life. Move at your own pace. Don't compete with anyone. Compete against yourself, and you're going to surely succeed. Set goals that are specific, set goals that are measurable, set goals that are attainable, set goals that are realistic, set goals that are time bound. With that, I believe you're going to succeed in life, and you're going to attain everything at its time. In life, everything is like a stairs. You cannot move from down to top just like that. You have to move each step at a time. Desire to move at your own pace. Don't compete with others. Don't compare yourself to others. So we are going to first define everything that is in our topic. Every word we are going to define it. So the word kinetic, we mean some. So when we talk about kinetic, we talk about something that is in motion. And when you talk about matter is anything that occupies space and has mass. That one we defined in the last lesson. So matter exists in three states: solid, liquid, and gas. So in this lesson we're going to study how the three states of matter interrelate with each other. So as you can see in this curve, this is a heating curve. Why? We are moving from a lower point to a higher point. So that is it. That is heating. We're moving from negative 10 degrees to 100 degrees Celsius. This is time. So from point A to B, we have solid. From point C to D, we have liquid. From point E to F, we have gas. So as you can see here, a solid particles are close to each other, and when they are heated, they vibrate about the mean position. Liquid particles are further apart. As you can see here, they have some sort of large intermolecular distance, but gases have larger intermolecular distance than liquids. So it is easier to heat a gas and reach its boiling point than a liquid than a solid. So that is just all about kinetic theory of matter. When you heat a substance, what happens? It gains energy and starts to move or starts to vibrate. That is all about kinetic energy. So today we're going to study about the heating curve, and a typical question that you'll find in an exam: explain what happens between point A to F. You can be asked, explain what happens A to B, B to C, C to D, D to E, E to F. First of all, what are you seeing? You first state your observation depending on what you are seeing. What are you seeing? At point A to B, what are you seeing? You know, some people just say chemistry is hard, but it involves just small, minor things. What are you seeing? From point A to B, what are you seeing? There is a rise. There is an increase in temperature. Just that. What are you seeing? That is what the first point, that is what you write in the first point. What are you seeing? Rise in temperature. B to C, constant temperature. C to D, rise in temperature. D to E, constant temperature. E to F, rise in temperature. So the chemistry behind the rise in temperature and the remaining of temperature constant, that is now what you are going to discuss. So let's move on and discuss what happens between point A to B. We have said that there is a rise in temperature. Why? From point B to C, the temperature is constant. Why? Why have we not stated the state at point B to C? Why have we not stated the state at point D to E? So those are some of the questions that we are going to answer in this lesson. So at point A to B, we have said that the ice is heated and the temperature rises steadily from negative 10 to 0 degrees Celsius. So that is just the first point. What are you seeing? The next point, why has the temperature risen? This is because the heat supplied increases the kinetic energy of the molecules. And the molecules are ice molecules, so they are solid molecules. they just vibrate, and the temperature rises from -10 to 0 degrees Celsius. As you know, what is the melting point of ice? 0 degrees Celsius, correct? So the temperature has increased. This is because there is increase in collisions between the particles of the ice molecules, hence there is increase in temperature. The basic rule of conservation of linear momentum is that energy can never be created or destroyed, but it can be transformed. The word transformed is like it can be changed from one form to another. We'll get into some more physics, but just some basics, because I believe most of you done it in Form 1. And we are converting. We cannot destroy energy, cannot create, but we can transform. We are transforming energy that is in the ice to kinetic energy. Kinetic energy is energy in motion. So we are transforming the energy that was in the ice. We are breaking the intermolecular forces in the ice and transforming it from kinetic energy now to thermal energy. When you hear the word thermal, what comes into your mind? Heat. Very good. So now we have said that the temperature rises. Why? Because the heat supplied increases the kinetic energy. Now we need to transform the kinetic energy to thermal energy. That is why the temperature increases. Hope we are together. Let's continue. What happens at point B to C? At point B to C, the temperature remains constant. I'd like you to note some of the terms that we are using. Here we said the temperature rises steadily. Here I've said the temperature remains constant as heat is applied. We are applying heat, yes, but the temperature is still the same. Why? This is because all the heat supplied is used to break the forces of attraction between the water molecules in ice. We said that the melting point of ice is 0. So when it reaches 0 degrees Celsius, it starts to melt. So point B to C is a process that we call melting. And melting is change of state from solid to liquid. So at point B to C, we have a mixture of solid and liquid. We don't have one state. That is why I have not stated the state at point B to C. So what happens at point B to C? As you can see, the temperature was constant. Now we are explaining why is the temperature constant besides us applying more heat. This is because all the heat supplied is used to break the forces of attraction between the molecules of the ice. So it is changing from solid to liquid. Let's move on. So at point C to D, the water is heated and the temperature rises. So now we have moved from ice, we are talking about water. Water is liquid. So the temperature rises. Why? Because the heat supplied increases the kinetic energy of water molecules. So the rate of collision of the particles increases. Let me take you back to physics, Form 1 physics. There is a chapter called Particulate Nature of Matter. In this topic we learned about Brownian motion. And in Brownian motion we say that particles are in constant random movement. Constant random movement. So they collide. And when they collide, for example, when a car collides with another car, sparks are released. So there is a change of energy there. From kinetic, the car were moving, so it was kinetic energy, and now it has changed to thermal energy. The sparks or the heat that is evolved when cars collide. Another good example, though it is funny, when you are slapped or when you slap another person, the cheek of that other person becomes hot. So you can relate some of the things. So there is increase in temperature there. Why? Because the rate of collision of the particles has increased. As to summarize this slide, what have we said? That at point A to B, the temperature does what? Rises. So at point A to B, there is a rise in temperature. And what is the state at point A to B? It is ice. So the temperature of the ice increases. At point B to C, the temperature does what? Remains constant. So when the temperature remains constant, we say that there is a change of state, and we don't have one specific state. So here we have solid and liquid, both solid and liquid states. So this process is what we have called melting. Then at point C to D, we have said that the temperature increases. The temperature rises again. So here we have also a rise in temperature. Why? Because the heat that is applied increases what? The kinetic energy of the water. So here we have water. So here we are in liquid state. We have moved from solid to liquid. So here we have water. Just that is just a summary. So that is a heating curve. Let's move on. So here we have points D to E. At point D to E, the temperature remains constant again. The temperature remains constant again. Even as we are heating, the temperature still remains constant. So we are changing the state again. When you see a constant temperature, remember we learned about the criteria for purity. We say that a pure substance has a constant melting or boiling point. So we have already melted the substance from solid to liquid. Now we are moving from solid to gas. So there is a change of state from liquid to gas. And that process is what we call evaporation. Very good. So here the temperature remains constant even as we are heating. Why? Because all the heat supplied is used to break the forces of the water molecules. Then at point E to F, the temperature of the vapor rises again. Why? This is because the heat supplied increases the kinetic energy between the particles, and this increases the rate of collision. Why are we talking about collision every time? We have said that matter is made up of particles, and those particles are in constant random motion. And when we heat, we increase the speed of the particles. And when we increase the speed, since they are moving randomly, they'll start colliding. When they collide, they transform their energy from kinetic energy now to thermal energy, and thus the rise in what? Temperature. I hope we are together up to there. So to summarize this slide, what have we said? We have said that at this point there is the temperature remains constant. So we have a constant temperature here, and this process is what we call evaporation. This process is what we call evaporation. And evaporation is a change of state from liquid to gas. And as you can see from the graph or the curve that we have, it has taken place at 100. It has taken place at 100 degrees Celsius. Then at point E to F, we have said that the temperature does what? Increases. So here we have a rise in temperature, and we are already at gaseous state. So here we have a rise in temperature, and this is a gas. So we can call it steam or vapor, whichever you want, provided it is in gaseous state. So here we have at point D to E, there is a mixture of both liquid and gas. So we don't have a specific state at point D to E. So let's move on, and we have moved from point A to B, B to C, C to D, E to F. So we have moved from point A to B. We have said the temperature rises. B to C, temperature remains constant. C to D, temperature rises. D to E, temperature remains constant. And now E. So for the assignment today, I want you to explain to me what happens when you heat a solid according to the kinetic theory of matter. So just move the way I've said. You'll start from gas to liquid to, we'll start from solid to liquid to gas, and that's all. And hope we have achieved everything. Now in the next lesson, we will study about balancing some chemical equations and also some important chemical symbols. So they are not to miss, and I hope you have enjoyed the lesson. In case you have any questions, you can leave them at the comment section. Thank you, and I wish you all the best in your endeavors.